I found a beautiful question. You got to see this. Check this out. This says the graph of an original function is this. It says I'm going to stretch it. I'm going to stretch it vertically. I'm going to stretch it horizontally. I'm going to translate it left, and I'm going to translate it up. But the point of all of this is I want to write the new equation for it. What does this mean? You are going to do a replacement. You're not going to do a mapping. Remember, mappings are for points only. You do replacements of equations. What do I mean by that? Well, take a look what that equation used to look like. The equation was always in this factor, this y equals to a f of, there's the b, right? X minus h, right? Plus k. But I gave you all that information in this question. Let's read it again and let's figure out what the A, the B, the H, and the K are all about. Then we could just substitute it in here, right? Sort of. Let's watch. Okay, this particular function is stretched vertically. So if we're stretching vertically, of course, about the x-axis by a factor of 3, we know we're dealing with the a value. Beautiful. We're stretching horizontally about the y-axis by a factor of 1/2. Wait a second. Don't get stung. B is not equal to 1/2. Remember, the stretch factor is 1/2, but the b value is 2. You got to flip it. Don't forget. Translated 3 units to the left. Okay, 3 units left means your h value is -3. 4 units up, your k value is 4. Done. There's your a, b, h, and k. So you know what? I'm going to pop this right into the equation right now. Okay, y equals to a, 3, function, b, 2, x minus a -3, which makes it a +3, right? And plus k, which is 4. Aha. Now, in order to do a replacement properly, you want all the horizontals together, you want all the verticals together. But here's the problem. There's a vertical here, there's a vertical here, there's a vertical over here, which is the y. Oh man, let's put all of those things together. Okay? Subtract 4 from both sides. Boom. That's gone, giving you this guy's gone now. Okay? This gives you y minus 4, right? Equals to, yep, 3f bracket 2x plus 3. And now that 4 is gone because you brought it over to the other side. Now, we got to get rid of this 3 here. So, well, simple. Divide each side by 3. That cancels out. And look what you have. This is the best part. You have y minus 4 over 3 equals to, yep, f of bracket 2x plus 3. Are you with me? Beautiful, isn't it? Yeah. So what was that original function? Well, the original function, oh, there it is, 3x squared. That's this guy right here. 3x squared plus x minus 5. Okay, let's put it in. Right down here. The original function was y equals to 3x squared, right, plus x minus 5. Are you with me? Cool. Okay. Now, what do we do with this? Well, we're going to substitute. This is a replacement. That means this y replaces that y. That means this is, if you remember, that's your f of x. That means that guy's going to go into here, and I know what you're saying. I don't quite get what you mean by that. Well, remember what you did way back in grade 10. If you're given a formula that says f of x equals to, let's say, 2x plus 5, and you're told that this is f of 4, right? You know that this 4 and this x, every x is replaced now by 4, right? So this would be 2 times 4, which is 8. 8 plus 5, which works out to be 13, right? So you'd say f of 4 equals to 13, right? Same idea. Look how this is going to go into every one of the x's. So what does this mean? Oh, simple. You're going to get this guy here. This is going to be y minus 4 over 3 equals to, check it out, 3, the f, this thing here, goes into every x. So this x squared plus this right here, x minus 5, they all get that 2x plus 3. Oh my, this is going to be interesting. Yes, it will. Okay, so let's put in the 2x plus 3. Okay, there's the 2x plus 3 right into there. There it goes. There's your substitution. Real simple, isn't it? Yeah, it's not that bad. Now, all you have left to do here, sports fans, is some algebra. Okay, granted the algebra might look a little bit weird right away, but you know what? It's not that big of an issue. Watch, it's very simple algebra. Let's leave this y alone. Let's leave this here 3. Now, let's square this puppy. If you square this, that's going to give you 4 and x plus 3 squared. Now, I know what you're probably saying to yourself. Well, wait a second. Why didn't you just distribute this 2 right in here like this? Do you remember what the horizontal transformation was? The horizontal transformation way back over here, the horizontal transformation was 3 units left. By leaving this as x plus 3, it actually shows you what the horizontal transformation is. 3 units to the left. Cool. Plus, there's the 2, x plus 3, so there's the horizontal translation again, 3 units to the left, minus 5. We're not done yet. We're not done yet, so don't count your chickens before they're hatched. Y minus 4 over 3. Look at this. Okay. Distribute. That's going to give you 12. This is going to be x plus 3. There's your squared plus, still leave it there, 2x plus 3 minus 5. Got it? Now, check this part out. This is the best part. You ready? Get rid of that 3. So you multiply both sides by 3. That cancels to give you y minus 4 equals to, okay, 3 times 12, I think, is 36, right? 36, that doesn't change, x plus 3 squared. That 3 now goes to the 2 to give you 6. Yep, x plus 3, right? That 3 now goes to the minus 5 to give you minus 15. Are you with me? Uh-huh. So there it is. Now, add that 4. You're still not finished. You're almost finished. There we go. Check it out. That's gone, leaving you y equals to 36. X plus 3 squared plus 6, x plus 3 minus 11. That is usually the answer in most textbooks. That's what you would get, because most textbooks want to show you that this, in fact, is the translation. Aha. Okay. I want to take this one step forward. I want to make sure that we can actually expand this puppy out. Well, let's do all the algebra. That'll be fun, won't it? Sure it will. Well, let's do the math. Okay, there's 36. There's x plus 3 squared. So x plus 3, x plus 3, there it is. There's the plus. Well, you know what? We can distribute this now because we're expanding it out, right? So this is now 6x plus 18 minus 11. Oh, beautiful. Now, everybody loves FOIL. So there's 36. There's your x squared. Your 3x and 3x will give you 6x. Your 3 times 3, which will give you 9. Oh, beautiful. 18 minus 11 is you 7. Wow, lucky you. Perfect. Keep on going. Distribute this. Bada-boom, bada-boom, bada-boom. You're going to get 36x squared plus 6 times 36 actually works out to be 216x. 36 times 9 actually works out to be 324. Oh my, that looks vicious, doesn't it? Not really. This is just simple grade 10 algebra. Combine the x's, you're going to get 36x squared plus, combine it, 216 and 6 gives you 222x, right? 324 plus 7 gives you 331. And that's your transformed equation into something really pretty. Wow. So you might on a test get this version like this. You might actually get this version here. You got to be able to, yep, change those from one to the other. Oh, that looks just monstrous. But how do we prove that we are right? Well, I want to put the original A, B, H's, and K's up again. If you remember, the A was 3, the B was 2, the H was -3, and the K here was 4. Do you remember that? Okay, now you're probably saying to yourself, how am I going to do this? How am I going to prove that those are even remotely close to what I've done? Honestly, I'll show you in the next podcast. Stay tuned.